Hello. After seeing Future War yesterday, I decided to take a walk around the universe. You know, you can do that in your mind. But we do have to study math. So what we're going to be talking about today is function behavior. More about function behavior. What do they do? Well, what do the graphs do? Because that's more obvious to us. Well, the graphs go up and down and they get flat and they've got domain and they've got range. And what does all that look like? Well, let's get to work and start finding out. Start finding out the secrets of the universe. Here, in another place in the universe. Aren't the animals cute? Ooh, they bite. Better not pet them. So here we go. Let me pull this out a little more. There now, that's better. Okay, we're going to be talking about a subset of the domain first. By subset of the domain, I mean it's part of the domain. Now, what is the domain of this graph? Let's make it bigger. Well, let's see, it goes up and down and flat and up and flat, and it goes to the right forever. And this arrow tells us that while it's going down, it also is going out to the left forever. And there aren't any breaks, or we'd be told about them. So I would say with some certainty that the domain is negative infinity to positive infinity, which is another way of saying the entire x-axis. The domain can always be found on the x-axis, just like the range can always be found on the y-axis. So let me write it down just so we'll have it. For reference, domain, the domain of this graph is the interval negative infinity to positive infinity. What we're going to be doing now is we're going to be breaking down this graph into where it's going up and down and flat and up and flat, always going from left to right. Which is just the way we read domain, left to right. And it's the way we do math most of the time, left to right. Okay, I'm going to divide this up into different colors, and I'm going to let green, which means growth, I'm going to let that represent movement up on the graph. So if we look from left to right, then this line is going up, 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 up. And it stops going up there. Now notice that, yes, this goes down, 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 but if we're reading from left to right, then this is going up. Now reading from left to right, the graph is going down, 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 down. All right, so down, 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 down. And then, kind of boring, the graph is flat here. Flat, 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 flat. But we're still reading left to right. And then the graph goes up again. Up, 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 up. And then the graph flattens down and stays that way forever. Oh, little arrows. Flat, 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 flat. I'll just leave that there. Flat. That's better. All right. So that's a very nice picture. But I need to be able to communicate this information to you. If you were to come up to me and say, hey, like this question does, oop, oop, there. List the intervals on which the function is increasing. Well, we have to talk about that because it's not what you think. Yes, the graph is going up and down and flat. Here, up and down and flat, up, flat. But for me to tell you where that's happening, I have to tell you where on the x-axis that's happening. So the graph is going up, 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 up from negative infinity on the x-axis to -7 on the x-axis. Okay, I'm going to draw a line through it. For this entire part of the x-axis, the graph is going up. And for this entire part of the graph, of the x-axis rather, the graph is going down. Notice that you can pair this up. Hello there, little Bubba. There he is. There he is. Say hello. I want my whole picture there. All right, all right, all right. All right. Let's let everybody see your whole picture. There you go. There you go. Say hi. Say hi. Say, oh, geez, she's doing it again. Okay. Commercial break is over. What do you want? You can't interrupt the video. But I am interrupting the video. I know. Say hi. Come on, it's time to learn math. Kiddies need math. Not sure why, but we can find reasons. All right, now, where were we? Aha! The graph is flat on this part of the x-axis. See, they pair up. Ooh, no, no. There. Somebody's purring. Right here. There. Yeah. For this part of the x-axis from -5 on the x-axis to -2 on the x-axis, the graph is flat. And then from, let's see, this part of the graph can be paired up with -2 on the x-axis to -1. What? The kitty cat is falling. Wait a minute, we have a crisis. I have bored him. Okay, from -2 to -1. For this part of the x-axis, that's a real little part of the x-axis. Let me make this bigger. Yeah, see, even though from here to here, we have the graph going up, where I say it's going up, how I give you directions on how to get there starts at -2 on the x-axis and goes to -1. And then the graph is flat again from -1 on the x. Not up there, not up there. You see how tricky this is? This part of the graph pairs up with -1 on the x-axis, going all the way to positive infinity on the x-axis. Now, once you've done this, it's pretty easy to list the different intervals on which, that's what we call it, on which the graph is increasing, decreasing, and constant. Constant means flat. So we'll do this. From -infinity to -7, and from -2 to -1, the graph has increasing segments. Notice you only use parentheses, you never use brackets. So let's make this an increasing color. Increasing for that interval and increasing for this interval. Okay, the reason for that, if you're wondering, why we always, when we're talking about increasing, decreasing, constant, why we only use parentheses, it's because you can't say about this end point, well, is that the end of increasing or is it the beginning of decreasing? A point can't be both at the same time. You have to choose. But you can't, because this point, -7, is the end of increasing and the beginning of decreasing. So rather than deal with split personality, we just stay with parentheses. Okay, now where is the graph decreasing? You can see it right there. But let's go take a look, which is what I'm trying to do right now. There it is. We've only got one place where the graph is going down. That's decreasing. And that's from -7 on the x-axis to -5 on the x-axis. Right there. List the intervals on which the graph is decreasing. Right there. So I will color it decreasing. And list the intervals on which the graph, the function and the graph are the same thing when the graph is drawn accurately. List the intervals on which the function is constant, flat. Well, there are two of them. Let's see. Flat. From -5 to -2 on the x-axis, and from -1 on the x-axis out to infinity on the x-axis. And that's precisely what we have here. On this interval and on this interval, the graph is constant. Not going up, not going down, just flat. And notice these words are typed in blue on my math lab. They tell you exactly how you should answer the question. And so here's our graph. The hardest part for students is to remember that you don't tell where on the y-axis the up and downs are happening. It feels like you should. I agree. But no, these are subsets, parts of the domain, and the domain is on the x-axis. So we have to give the directions on the x-axis. Kind of like giving street directions. Right? If I want to go see the fireworks, the 4th of July fireworks, which I had to listen to, and my cat ran away. He was so scared. I didn't close the cat door in time. It was a soap opera. Yes, anyway, that was going on last night. But if you had invited me over to your house to look at the fireworks are up in the air. But you don't invite me to 50 feet in the air. You invite me to your house. You give me your street address. It's the same thing here. Okay, now we're going to speed this up with less explanation. Really? There was just that one? Yeah, all right. Next page. From the graph, state the intervals on which the function is increasing, decreasing, or constant. So we come over here. Now this is the way we draw graphs to show they continue forever. But when we're talking about increasing, decreasing, and constant, we go left to right only. That's hard to remember too. Left, infinity. To right, whoop, negative infinity, duh. To right, infinity. All right, so I can draw my little picture where from left to right, the graph is going down, 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 down. From left to right, the graph is flat, 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 flat. You could have a great time with your kids doing this. What's the graph doing now? Flat, 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 flat. And you would be teaching them so much. All right, and from here to here, the graph is going up, 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 up. You could even have them doing little hand motions. There are all sorts of ways to entertain yourself with math, to make math more fun, so it doesn't just have to be a drag. Why be miserable? You've got to do it, so have fun. Seems easier to me. Drag your cat onto your lap. See if the cat can help. Okay, or the dog. Here we go. We have to say where this stuff is happening. Well, and we have to say on the x-axis. Notice this graph is kind of up in the air. Here's the x-axis right here. I need to make that darker. Just so I'll see it. Old lady, you know. Whoa, that's a monster. Yeah, okay. There, okay. Here's the x-axis. Okay. Now, from negative infinity to whatever that is, let's see, if this is -6, -5, that'll be -4. Let me write that down. The graph is going down. For this part of the x-axis. For this part of the x-axis, from -4, 5, 4. This looks like 4, doesn't it? No, it doesn't. 5, 4 right there. Here we go. The graph is flat from -4 to +4. And the graph is going up from +4 way out to the right forever and ever to positive infinity on the x-axis. All of it on the x-axis. So now we can write our intervals. The function is increasing on what interval? Oh, increasing is over there, from 4 to infinity. The function is constant on what interval? -4 to +4. Right there. Don't choose that one. Choose this one. No brackets. Let me mark that. Constant. That's not a constant color. No brackets. Really obnoxious. And the function is decreasing from negative infinity to negative 4. Decreasing, negative infinity to negative 4. No brackets. Not that one. Let's mark out all the brackets and write no brackets, just to help you remember. And here in increasing, there's a bracket, so that should be the answer. This would not be the answer. No brackets. There. Okay, no brackets. Could have your kids shake their hands at your homework. No brackets. Yeah, just emphasize it. See, we could have elementary school kids learning this stuff. Would that be scary? Okay, we're going to do the same thing with this graph. But I promise we will do it faster now. Okay, so let me write negative infinity and positive infinity. Here's the x-axis. Sometimes it's hard to see. Don't think I'll make a monster x-axis. Although it can be fun. All right, so this is kind of like that other graph. We're going, there. We're going up. We're coming down. Down. We're going flat. Flatlining. We're going up. Oh, I stand no chance. All right. That's a long line. I'm going to have to cheat a little bit. There. And flat. And then once you've determined this, you just pair it up with the x-axis. Negative infinity to negative 6. Uh-oh. Wrong color. There we go. Okay. Whew. Pair this up. That looks like -1. Well, Barbara. -1 to, no, -1 to 0. Because this is 1 right there. My goodness, it's such a long line, and look at the short interval. That's interesting. From -1 to 0. X equals -1 to x equals 0. All right, now going down. Here from -6, pair that endpoint up with -4, and it's not going down anywhere else. And constant from, see here it is there, so from -4 to -1, and from x equals 0, the y-axis, out to, see, I did that before. Here, from x equals 0 all the way out to positive infinity. So we have 2 browns, 2 greens, but only 1 violet. So now let's check this out. Increasing -infinity to -6, check. -1 to -0, -1 to 0. Right there. Cool. Decreasing. Well, there's this, -6 to -4, got that, and there's only one decreasing. And the constants from -4 to -1, -4 to -1, got that, and from 0 to infinity. 0 to infinity. Now that's a long line. Okay, that's how you do this quickly. It helps to not have your teacher talking while you're doing it. Okay, look back over this. You can look and see easily what is going up and what is going down if you remember to go from left to right. The hard part is transferring that down to the x-axis. So you have to work on that. And no brackets, no brackets, no brackets. Yes. No. Okay, now we're just going to go to domain and range so you can see the difference and be introduced to the concept of solid filled in holes as opposed to open holes. Well, we only have solid filled in holes here, and it looks for all the world like we're about to give increasing and decreasing intervals, but we're not. See, they're tricking us. They want the domain and the range. Well, I'm going to let blue be the domain. And red, well, red-ish, be the range. I could make it red, but a lot of people can't see red. What makes violet different from red is that there's a lot of blue in it. So people who can't see red can usually see violet. Maybe it looks blue, but they can at least see it. It's very common to not be able to see red. Okay, enough of that. Let's look at this. That means the graph actually starts here and stops there. Okay? We have definite beginning and endings. None of this from negative infinity to positive infinity stuff. What's more, when you have filled in dots, you use brackets for domain. For domain, you can use brackets when it's appropriate, but not for increasing, decreasing, and constant. You're going to have to remember that too. All right, the graph starts here. Remember, we always go left to right. The graph starts here at, looks like -6. Starts here and goes all the way to here, 6. And because x actually equals -6, and how do I know that? Well, I know it because, see, I put those there. I know it because these are filled in circles. So x equals -6 and y equals, looks like -4, right there. They're actually going to equal. That's when I use brackets. So there you go, there it is right there. The domain of the function is bracket, bracket, -6 to 6. That means -6 and 6 on the x-axis are included in the domain. So we'll put blue brackets. No, we won't. Yes, we will. Bracket, bracket, domain. Now the range is on the y-axis. So I'm going to use violet for that. What is the very lowest point on this graph? Looks like -4. What is the very highest point on the graph? Looks like +4. So the range is going to go from -4 to +4. And we're going to use brackets there as well when we write it on paper. Notice that we go from left to right for domain, but for range, we go from lower or lowest to highest. Again, I keep having these visions of you know, you've got to do your homework and your kids really like to be with you. So you know, like here you go, you get them to say lowest and then highest. Yeah, you can kind of tune that out if you want to. But you do use brackets when it's appropriate with domain. Now, here is an interesting graph. We're going to do domain and range. Again, I know you know domain and range, but we have to be able to compare. Compare and contrast, right? Just like in an English class or a communications class, you compare and contrast. I always hated comparing and contrasting. But you've got to do it. Okay, now, notice that this arrow means that the graph continues down, 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 down. Well, it continues to the left also. And it continues to the right. So our domain is going to be all the way to the left and all the way to the right. So our domain is going to be from negative infinity to positive infinity. Not from negative 10 to positive 10. These arrows tell you the graph goes way beyond negative 10 and positive 10. So yes, this is our domain right here. This is our domain. Now, something we usually don't talk about, but it's true, and that is that the y-axis also has a negative infinity down here and a positive infinity up here. So, if this graph keeps going down, and it does, or it wouldn't have an arrow there, the graph keeps going down, 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 down forever, but it doesn't go up forever. It goes up to y equals 1, 2, 3, 4, goes up to 4, and then it doesn't ever go higher than that. So your range goes from negative infinity to 4. And y actually equals the number 4 at 4. So you've got a bracket there at 4. This says the graph starts at negative infinity and goes forever and comes to a screeching halt at y equals 4. That's the range. Lowest to highest. Left to right. I don't guess it's appropriate to say leftist to rightist. Sounds political. Okay. And now this problem has a video that you can watch if you need more explanation. We're going to do now a new topic. New topic! We're going to be talking about relative maxima and relative minima. So, this is a lot like what we did with quadratics. Very similar. So you should not have much of a problem. Let's look at this. This graph, since it's blue, I'm going to continue in blue. This graph goes down forever and up forever, as well as to the left and to the right forever. So this point is not the highest point on the graph. Any point up here is going to be higher. But, if you can imagine, in its own little neighborhood, that point is the highest point. In fact, it's the top of the hill. And then you go down again, not to the lowest point on the graph, because any point down here would be lower, but in its own little neighborhood. This point would be the lowest point. It's a valley. So you have a hill and a valley. Now, we discuss hills are called relative maxima. That's the plural. There's one hill is a relative maximum point. It's not called a vertex, but it is called a relative maximum point. Okay, now much the same over here. A valley is a relative minima. Well, valleys are, if we say plural. Valleys are is that the way you spell valleys? I think it is. Valleys are relative. It looks funny though, doesn't it? Somebody should look it up and let me know. It's the way the notes are expressing it. Don't let that animal bite me. Looks kind of irritable, doesn't it? Okay. Valleys are called relative minima. Minima. One valley is called a relative minimum point. We have a relative maximum point and a relative minimum point. -4, -1 is a relative, there's more to it than this, relative minimum, maximum. Relative maximum point. And our value for -33 is a relative minimum point. Well, you remember how with quadratics, when we had a vertex, the x coordinate could be time, it could be items produced, it could just be numbers on the x-axis, where the maximum value or minimum value occurs. We have much the same thing going on here, but not exactly. Because after all, these are a little different from vertices in a quadratic graph. Here is how you analyze relative maxima and relative minima, or relative maximum points and relative minimum points. For the relative maximum point, let me write down what it is. -4, -1. The relative maximum is just like the relative maximum value is the y value, -1. The relative maximum is -1. At x is the location. X equals -4. So this is the value. Let's say y is the value and x is the location. Same thing for the relative minimum. Our relative minimum point is for -33. -33 is the relative minimum. If we were working with quadratics, we would say the relative minimum value or the minimum value, forget relative. If we were working with quadratics. But here, it's just called the relative minimum, and it's the y coordinate, the value. Whereas its location is at x equals the x coordinate, which is 4. Yup. There's nothing to say other than that. Except coming back over here. Now I have to do something if I don't want everything to get all messed up. I have to flatten my annotations. There. Okay, otherwise what I'm about to do would mess everything up. We're going to talk about increasing and decreasing. Oh joy. So increasing, I'm going to make it fatter. Increasing You recall we go from left to right. Increasing. Decreasing. Increasing. So increasing, 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 increasing until you hit the relative maximum point. And that's the turnaround point. Then you start decreasing, 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 decreasing until you hit the relative minimum point. And then you go back to increasing, 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 increasing. I seem to be 5 years old today. The relative maxima or relative maximum points and relative minimum points are the turnaround points. So now we're going to talk about that. On which intervals is the function increasing? Well, all right, we've got to find our intervals. They're on the x-axis, remember? So this is negative infinity out here, all the way into -4, the x-coordinate of the relative maximum point. So from negative infinity to -4, the graph is increasing, and from the x-coordinate of the minimum of the relative minimum point, we start increasing again and going out to, going forever. So here are our answers. Negative infinity to -4 with parentheses, and 4 to infinity. Now notice this. Sometimes you're going to see it written like this. Negative infinity to -4, comma, 4 to infinity. Because what you're doing is you're just listing the intervals. You never use a union. Not with increasing, decreasing, or constant. You do use union signs when you're working with domain and range, when it's appropriate. When you have a split domain, for instance, you put a U between the parts, but not for increasing and decreasing and constant. That's another difference. Something you have to keep somewhere in your brain. Now decreasing. Let's go find it. Don't take anybody's word for it. Here's our decreasing segment of the graph, and it lines up with -4 on the x-axis, which is the x-coordinate of the relative maximum point, and all the way to the x-coordinate of the relative minimum point. right there. So from -4 to +4 on the x-axis. Let's write that down. -4, +4. Right there. This is the x, -4. In fact, this is so important. -4 is the x coordinate of the relative maximum point. And 4 is the x coordinate of the relative minimum point. I know you're thinking there's so much to remember. There is. That's what makes college algebra different from other math classes. The more you've learned before, the more you can bring it with you and have less to remember. Okay, we could also ask about domain and range. I wonder if they do. No, that appears to be it. Here we have a quadratic, a cupped down parabola. We're used to dealing with those. Okay, now if we treat this quadratic like any polynomial we might graph, then notice that our vertex becomes the relative maximum point here. So the vertex is the same as, well, for a cup down parabola, relative maximum point. Your relative maximum and your maximum value are the same thing. Relative maximum equals maximum value, K. So let's put a K. K is the relative maximum, which is the same thing as the maximum value. We called it the maximum value. So now we're going to talk about what else H is. So we've got HK, right? H is the location of K, among other things. The relative maximum occurs at this location, which is our H value, negative B over 2A, and has a value of. The relative maximum is the maximum value. This is K. So here's the sentence. The relative maximum occurs at x equals negative 4.5, and has a value of 6.25. The vertex of a parabola is just another relative maximum point, or if you have a cupped up parabola, relative minimum point. And now we're being asked about increasing and decreasing. Oh my goodness. Okay, increasing. Increasing, 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 and decreasing. Oops. Oops. Decreasing, 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 decreasing. And so they don't show us an x-axis, but we do know that this x-coordinate is negative 4.5. So somewhere, there's the x-axis. Doggone if that isn't hard to see. There. I'll go back to 1. All right, we've got negative infinity out here. We've got negative 4.5. Negative 4.5, because that's what they say it is. All right, then we're going to be increasing on the interval negative infinity to negative 4.5. There it is, right there. And we're going to be decreasing on the interval negative 4.5 to positive infinity. This interval. Negative 4.5, infinity. This is decreasing. This is increasing. So let's see, where is the function increasing from negative infinity to negative 4.5? On the x-axis. Where's the function decreasing from negative 4.5 to infinity? On the x-axis. Finally, one more to kind of cement everything you've learned. Your relative maximum point is -6, -1. Okay. Relative max point is -6, -1. The relative minimum point. Why did I do that? The relative minimum point is 0, -19. And here's how that breaks down. The relative maximum is -1 at x equals -6. This is the value. This is the location. I should say y is the value, x is the location. Now, the relative minimum is -19, the y value, located at x equals 0. See, this is where, well, this is where the x-axis and the y-axis, whoa, cross. Right here is x equals 0. Now, on which intervals is the function increasing? Man, they are hitting us over the head with these concepts. All right, left to right. Up, 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 and up, 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 up. Increasing -infinity to the x coordinate of the local maximum point, -6. And the x coordinate of the local minimum point out to positive infinity, all on the x-axis. So that should be -infinity to -6, 0 to infinity right here. So let's say it out loud. On x-axis. And I bet they're going to ask about decreasing. Down, 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 down. There, going down, decreasing. From the x coordinate of the local maximum point, relative maximum point, to the x coordinate of the relative minimum point, -6 to 0. And there it is right there. So let us write on the x-axis. Now that's an interval, remember, from -6 to 0 on the x-axis. Okay, you want to take notes. I persist in saying the best way, the very best way for your memory to take notes is on flashcards. Or you take notes on paper, but you write out the important stuff that you have to remember on flashcards, and then you actually use them. You don't just make them and set them aside. You can memorize an enormous amount of stuff with flashcards, more than you ever thought possible. So I'm going to go prepare this video and wish you a happy day studying. Bye-bye. I guess I'll have to transport back to Earth. Yeah, because that's where all my equipment is. Oh well, I'll say goodbye to the creatures and I'll see you soon.